So, chapter 2 is on functions and graphs. In section 2.1, we're going to look at the new function. It's called the modulus function. So the definitions of the modulus function is the following. When your f of x is greater or equal to 0, then the modulus of f of x is equal to f of x. However, if f of x happens to be negative, then the modulus of that needs to be representing a positive value, so it's the same as minus f of x. So really what it means, whatever is negative, it changes into a positive equivalent, but so the same size but opposite in value, so it changes into positive, and if it's positive, it stays positive. It's also called an absolute value. So you do have a calculator key called abs, and that simply calculates the absolute value of any number, changes negative values to positive. That's what it means. So for example, modulus of 6 is 6, modulus of minus 6 is still 6. There you go. So the first thing is to get used to it. So in example 1, we're going to find the modulus of minus 2, that's simply 2. The modulus of 6.5, that's simply 6.5. And the modulus of a third minus 4/5. So work it out. A third minus 4/5 is 5/15 minus 12/15. So this is the same as modulus of minus 7/15. Since modulus turns negative numbers to positive, it's 7/15. Okay, so here's a function that is f of x is equal to modulus of 2x minus 3, and then add 1 to that. So evaluate f of 5. So it simply says put 5 into this instead of x and work it out. So if you do it on the calculator, you can pop it all into the calculator with the modulus symbols. I quite like to be able to do both ways. This means 2 times 5, which is 10, minus 3, modulus of that, plus 1. 10 minus 3 is 7, so it's 7 plus 1, which is 8. So do the second one with the calculator. You put minus 2 this time, and then you're going to get minus 4, and minus 3 gives me minus 7, so it's modulus of minus 7, add 1. Modulus of minus 7 means 7, so it's 7 add 1, the answer is 8. So if I show you, just find the absolute value, do it with a calculator. So looking for the ABS symbol, which is there. Okay, so it's only open brackets. So I'm going to put, let's actually put minus 2 first. Minus 2 equals, press it on. Okay, minus 2 equals, and you do the absolute value, and you have 2 times ans minus 3, and then go outside the absolute value plus 1. So the answer is 8. And then if you want to put 1, it's 2 times 1 minus 3 plus 1. So this is going to be minus 1 modulus of that, which should be 1. 1 plus 1, which is... Okay, so I'm going to show you how to sketch the graph of y equals modulus of ax plus b function, and also a curve y equals modulus of f of x. So to begin with, when you sketch this, you're going to sketch a straight line, y equals ax plus b, and that straight line, let's imagine it looks like this. It's a general line, there you go. Intercept here with the y-axis is b, and when y is equal to 0, x is going to be equal to minus b over a. So now we need to understand that when you take the modulus of this function, so of ax plus b, that means my y values have to be always positive. So what does it mean? It means that you'll definitely keep that part of the straight line because it's always positive. Now for those values of y that used to be negative, when I've drawn the black line, so the black bit underneath the x-axis, the modulus sign will turn all those values to positive. So for example, let's imagine this value here had a y value maybe -1. Now that value is going to be turned into +1. Maybe this one for over here was -2. Now it will turn into +2. So effectively, -1/2 will go to 1/2. You will have a reflection of that part of the straight line that generated negative y's in the x-axis, so that now it generates positive y's. So this is the V shape if it's a straight line that's been you've taken the absolute value of, so the modulus of. So any straight line will always be a V shape. Now imagine you are got a curve. Let's just draw maybe a cubic curve. Okay, and now this one is y equals f of x. But now I want to sketch modulus of f of x. What does it mean? It means that y has always got to be positive. So when the curve was above the x-axis, that part will always correspond to positive y values, and so will this part as well. So you've got those two sections. Now the parts that were negative, the modulus will attack them, change them to positive, so you will reflect them. So those two parts, the new parts, they will be reflected, so you will not have those parts in your final answer. You will have only the pink bits over here. So anything under the x-axis gets reflected, anything above the x-axis stays where it is. So we're going to have a go at example 3, 4, 5 and 6, and then you'll be able to go on to exercise 2a. So example 3, we are going to sketch y equals modulus of 3x minus 2. So the first step is to draw the line y equals 3x minus 2. So it's gradient 3, intercept minus 2. So something like this. Intercept minus 2 when y is equal to 0. 3x minus 2 is equal to 0, giving us x is equal to 2/3. So to complete the sketch for the modulus of that line, we're just going to keep the part that's above the x-axis and reflect anything that's under the x-axis. So this value from -2 will go to 2, which you could find out by substituting x equals 0, and to obtain y equals modulus of 3 times 0 minus 2, which is modulus of -2, which is 2. So there we go. And that's our graph. You also need to be able to solve equations. So I'm going to show you a very simple equation, and I'll show you how to solve it algebraically, and then we can have a look at the graph, how that corresponds to our graph. So modulus of 2x minus 1 is equal to 5. What does it mean? It means that anything in there, that 2x minus 1, must be equal to 5 or minus 5, because then when you've taken the modulus of that, that turns into 5, because plus and minus 5, that is the only possible, the modulus of the plus or minus 5 is the only way of obtaining 5. So we can solve two equations. 2x minus 1 is equal to 5. 2x minus 1 is equal to minus 5. So some people, well, sometimes it's necessary. Sometimes people just change this expression into minus 2x plus 1 and make it equal to 5. So either change 5 into plus or minus 5, or change this into minus 2x plus 1. So solving the equations, you have 2x is equal to 6, x is equal to 3, and here 2x is equal to minus 4, x is equal to minus 2. Always check by substituting the values into the original equations. So if x is equal to 3, modulus of 2 times 3 minus 1, that gives me modulus of 6 minus 1, 5, which is 5, so that works. And when x is equal to minus 2, 2 times minus 2 minus 1, that gives you the modulus of minus 5, and that's 5, so that works also. Now let me show you the graph, how that looks on a graph. So you need to think of it as finding the intersection of two graphs, y equals modulus of 2x minus 1 and y equals 5. So if I sketch y equals modulus of 2x minus 1, so draw y equals 2x minus 1 first, so it's minus 1, and that's going to be a half when you make y equals 0. So let's reflect it. So that will go through 1, that's a half, and then we'll draw y equals 5. Now the points of intersection, there are 2 of them. Point A you will find by taking the equation of this line, which is 2x, y equals 2x minus 1, and make it equal to 5. So 2x minus 5 minus 1 equals 5. That corresponds to 2x, 6x is 3. Now to get the second solution, you need to think what is the equation of this line. Now this line, so let's call it point B. The equation of that line, the reflection of this line is, well, it's minus 2x plus 1, because it's opposite gradient and plus 1. So we're going to solve equation minus 2x plus 1 equals to 5, because we find the intersection with this. And when you rearrange it, you get minus 2x is equal to 4, so x is minus 2. So you get the same solutions. Let's look at example 5. So here we have another equation, modulus of 3x minus 5 equals to 2 minus a half of x. I would recommend it, it's like, we are going to sketch it, but I would recommend doing it algebraically and checking that your answers work in the equation. Thus, if they don't, you can reject them, because it's possible that you'll find answers that don't work. And if they do, then you keep them. Now we're going to sketch it just to show you graphically. So there's 2 ways of doing it. So one way is making 3x minus 5 equal to 2 minus a half of x, or minus 2 plus a half of x, or, and that's the way I'm going to do it, just so you see a different way, rather than changing this to opposite values, I'll change this to the opposite values, because whatever is in the bracket could be equal to 3x minus 5 or minus 3x minus 5. And then you're going to make it equal to 2 minus a half of x in both cases. So rearranging it, the half of x becomes 3.5 of x, so 3.5 of x, and then you've got 7 on this side, so x is equal to 2. And this one here, we have minus 3x plus 5 equals to 2 minus a half of x. Rearrange that, you will have 2.5 of x on that side and 3 on that side. So x is equal to 3 over 2.5, double the top, double the bottom, and do it on the calculator, please don't make mistakes, is 6 over 5 as the second solution. If you wanted to have a look what it looks like when you sketch it, because it's important that you practice sketching as well, you would have to draw the line y equals 3x minus 5 and reflect it in the x-axis. So it's the line with a positive gradient of 3 but goes through minus 5. There you go. We're going to straight away reflect the bits that are under the x-axis. So this value here is when you make y equal to 0. So this is 3x minus 5 equals 0, giving us x is 5 over 3. And this point here used to be the minus 5 intercept, now it's 5. So let's just go over this in pink. So this is the modulus of 3x minus 5. Now the second line, let's draw the line y equals to 2 minus a half of x. So it's minus a half of x plus 2 if you prefer to write the gradient part first. So it intercepted 2, it's a negative gradient, it's quite a shallow line. So let's find the intersect with the x-axis. So when y is equal to 0, because with the y-axis is 2, but with the x-axis y is equal to 0, giving us a half of x is equal to 2, so x is equal to 4. Okay, so there are 2 points of intersection corresponding to 2 solutions, A and B. Now this line is the positive branch of y equals modulus of 3x minus 5. So to find point A, you're going to keep the positive 3x minus 5 and find the intersection with the line y equals 2 minus a half of x. So you are going to solve it and you're going to get 3.5 of x is equal to 7. So that was 2. We've already done that before. So that gave us 2. 0, so x is equal to 2 is solution. To find B, over here we need to take the reflected branch of the V shape, so that's going to be minus of that. So it's minus 3x minus 5 is equal to the line 2 minus a half of x, and we already solved that one, so x is equal to 6 over 5. There you go. So there's one more example, example 6, before exercise 2a. So example 6 is inequality. So modulus of 5x minus 1 is greater than 3x. So let's first of all find the solution to the equation. So modulus of 5x minus 1 is equal to 3x. So we'll do it algebraically. So we're going to make, find the solution to 5x minus 1 equal to 3x and minus 5x minus 1 is equal to 3x. So this will give us 2x is equal to 1, x is a half. And this one here, it's minus 5x plus 1 is equal to 3x, giving us 8x is equal to 1. So x is equal to 1/8. Now, the best thing to do, although there is a way of doing it without sketching, but we're going to sketch it, and then I will explain how else you could do it without sketching, because there will be two values on a number line that we're going to look at. So we'll come back to this. Now, the first one, we're going to sketch the line modulus of 5x minus 1. So it's a positive gradient, goes through minus 1, so it's something like that. But we are going to flip it. Let's do this one in pink again. So you're going to keep this branch and flip this one over here. So it's going to become 1 from minus 1. and that point was when y is equal to 0. So 5x minus 1 is 0, x is 1/5. And the second equation we're going to sketch is y equals 3x. So the line y equals 3x, let's do this one in blue, goes through the origin. This line is not as steep as the line with a gradient of 5, so this line will intersect both branches because that's steeper than the blue line. So there are 2 points of intersection. So again, we can think about it and find them again, but we've already found those points of intersection. So 1/8 is a smaller value, so it must be this one here. So that will be 1/8, and this one here is 1/2. I'll write it up, 1/2. So the question is asking you, when will the modulus of 5x minus 1, so the pink graph, be greater than the line 3x? So when is the pink bit above the blue bit? So the pink bit is above the blue bit for all these parts, then it has a break, and then it starts again over here. So with the graph, we're going to go for all the values of x all the way up to 1/8, and for the values greater than 1/2. So the solution is going to be x is less than 1/8 or x is greater than 1/2. Or you could put or symbol like this. Okay, now if you are rubbish at sketching graphs, how would you be able to find the solution from these 2 values? I will draw them plot them on the number line, and then pick a value that is less than 1/8. So let's pick. So choose some values. Pick x equals 0. So what we're going to do is substitute 0 into this inequality. So it's 5 times 0 minus 1, and then on this side is 3 times 0. So you have 0, and then you've got modulus of minus 1, so it's 1. And the symbol is greater. Is that true? Is 1 greater than 0? Yes. So you are going to keep all the bits to the left of 1/8, not including y-derivative because you have a strict inequality. Then you can pick a value between 1/8 and 1/2. So pick maybe 1/4. So let's say x is equal to 1/4. Let's put into the left-hand side 1/4. So, and the right-hand side, let's put 1/4. So I don't think it will be working because you normally have a gap, but let's check. 5/4 minus 1 is 1/4. Is it greater than 3/4? No. So we don't want this part here, reject that part. And finally, if you do need to test, let's pick a value greater than 1/2, maybe x equals 1. So we're going to put 5 times 1 minus 1 on this side and 3 times 1. If it becomes greater than, if it satisfies the inequality, then we keep that side. So it's 5 minus 1 is 4. Is 4 greater than 3? Yes. So that is part of the solution. There you go. So now you can go on to exercise 2A.